But however, like as we discussed, even if we use a collar, we have an issue. Why? Because there is going to be a speed differential between the output gear and the output shaft, right. Suppose if I want to go from gear 1 to gear 2, so let us say gear 1 is rotating at some omega 1. So the output shaft would be rotating at omega 1 when it has been connected to gear 1. Now we want to shift to gear 2, gear 2 is rotating at omega 2. Now the output shaft is going to rotate close to about omega 1. Then the question becomes, how do I engage them smoothly, right. That becomes a challenge with this collar arrangement. So that is the reason why we have moved to the synchronizer. So let us look carefully at how the synchronizer achieves this action much better than the collar. Okay. So let me, oops, 1 minute, sorry about that. So let me paste the schematic on the next page so that it is clear. Okay. So this is just a schematic of a synchronizer. So what happens here is that the synchronizer, let me first label the components, only one side has been shown, okay, for simplicity. This is once again a schematic. It has essentially a hub, okay, and it has what is called as an outer sleeve, okay, which slides on the hub, and it has these blocking rings which are nothing but rings with a conical cavity. Okay. So that's those are some key components in this synchronizer. So what happens is that if you look at this outer sleeve, so if you look at key components, we have a hub, we have an outer sleeve, and we have these blocking rings. There are 2 blocking rings, one on either side. Okay. The hub is connected, is mounted on the output shaft. So any rotation of the hub is going to result in rotation of the output shaft. This outer sleeve has teeth on its internal surface, inner surface, and can slide over the hub. Okay, so that is the arrangement. Okay, and these blocking rings have a conical cavity. So these are the 3 main components. So let me come to this schematic, okay, and explain how it works. So when a synchronizer is in neutral position, that is, it does not engage with any of the gears, this is how it is. Okay. So you can see that there is a gap between the this is the output gear which is under consideration. So you can see that there is a gap between the output gear's conical projection and the blocking ring, which is a conical cavity on the synchronizer. Now how do we engage the synchronizer? There is a synchronizer groove. So there is a groove which runs along the periphery of the synchronizer. So you can see this groove, right, and the so called selector fork which is attached to the selector rod, that is moved by the driver rests in this groove. Suppose I give a motion to this selector fork to the left. So, what happens is the following: this selector fork, right, first pushes this outer sleeve over the hub. So, there is an outer sleeve which is mounted on the hub, right. The hub has teeth on the periphery, outer sleeve has corresponding meshing teeth on the inner surface. So, you can see that now the outer sleeve is moving, sliding over the hub. When it slides over the hub, it is pushing this blocking ring against the conical projection on the output gear. So, this is an intermediate stage where the blocking ring is pushed by the outer sleeve against the conical projection on the output gear, right. Then what happens? Due to this action, the speed differential between the output gear and the synchronizer starts to reduce. So, the speed difference starts to decrease due to this action. Now, the outer sleeve continues to move. Okay. During the first phase of displacement of the outer sleeve, the blocking ring is pushed against the cone and the speed differential is reduced. The outer sleeve is further displaced, due to which it will travel past the blocking ring, and then the teeth on the inner surface of the sleeve will then engage with the teeth on the side of the output gear, okay. And then the synchronizer and the output gear are locked with one another, right, because the teeth have meshed with each other, okay. Then the entire unit is said to be synchronized, because the output gear, the synchronizer and the output shaft will be rotating at the same speed and the energy will be transferred, okay. So, this is the way in which the synchronizer achieves this task, okay. So, let me write down the main points so that we recall them later. So, the synchronizer has a cone shaped groove that slides on a corresponding cone shaped projection on the output gear. Okay, when the synchronizer is first shifted. Okay. So, first action is that the outer sleeve is moved or displaced on the hub by the selector fork. Okay. So, that is the first step. Then this cone shaped groove on the blocking ring goes and links with the cone shaped projection. This starts to reduce the speed differential between the output gear and the synchronizer. Okay. So, then what happens? The output outer sleeve travels further on the hub and the teeth on the inner side of the outer sleeve mesh with those on the output gear. Okay. So, it is now that the entire unit is synchronized and then energy is transferred to the output shaft. Okay. So, this is the sequence of operation in a synchronizer. Okay. Now, how does this gear transfer take place, like in a multi-speed gearbox? That is something which we are going to look at. So, if we look at a simple schematic of a multi-speed gearbox. So, let me just insert the figure here. So, let us say we consider a multi-speed gearbox, and let us say in the stick shift the pattern of gear selection is this. Okay. So, if we look at this schematic, so in this schematic this is the input shaft, okay. This is the lay shaft or the counter shaft and this is the output shaft, right. So, and we can observe that there are 3 synchronizers, 1, 2 and 3. Okay. So, these are the 3 synchronizers, right. And the reverse gear, this is a reverse gear arrangement which is achieved by what is called as an idler gear. Okay. We will come shortly to that. Okay. So, now what happens is that, like in this arrangement, this is the first gear, the way this schematic has been set up. So, this is the first gear. So, if I want to engage the first gear, what do? I push this synchronizer to the left. Okay. So, that corresponds to in the stick shift coming to the left and going down. Okay. So, that will push the synchronizer to the left. Now, if I want to come to the second gear, what I will do? I will come up in the stick shift, go to the right and go forward, right. So, what that will do is that, like, it will essentially take take this next synchronizer and engage with the second gear. Okay. And if I want to essentially engage the third gear, I just need to push it down, then this synchronizer is moved to the other side and it engages with the corresponding gear. Typically, in most manual transmissions, fourth gear is what is called as a direct drive. So, what is a direct drive is that the synchronizer directly connects the input and the output shaft in this configuration. In essence, the gear ratio is 1. So, what happens is that when you select the fourth gear, this synchronizer moves like this and then directly engages the input gear and the output shaft. Okay. So, that will be the fourth gear. Fifth gear is this way, you move this way and then like it engages with the fifth gear. Typically, fifth gear is an overdrive gear. So, that is the method in which we essentially use this multi-speed gear set, right. So, if we engage the first gear, what is going to happen is that, so the path of energy flow is going to be like this. From the input shaft, it will come to the lay shaft. From the lay shaft, it will go to the corresponding first gear pair. From the first gear pair, it will go to the synchronizer and then to the output shaft. Okay. So, that is how the energy flow will happen. Okay. So, that will be the path of energy flow. Fine. So, let me quickly show you, like how these various gears are engaged, okay, by just using a series of schematics, right. So, as we observed, So, this is the what to say neutral position. So, you can immediately see that when you engage the first gear, this synchronizer move to the left, right, and this is the path of energy flow. Now, when we want to engage the second gear, you can see that this synchronizer move to the right, right. So, this is the second gear. So, this was the first gear, right, and then the energy flow is shown appropriately. Now, when we come down from 2 to 3, what is going to happen? This synchronizer is going to be shifted to the left. So, that is what you can observe. So, you can see that the same synchronizer is now shifted to the left, and then we have the third gear which is chosen. Then we essentially choose the fourth gear. You can observe what happened in the fourth gear, right. So, this synchronizer just engaged the input gear directly. Okay. So, we have what is called as a direct drive here. So, we can observe that the input shaft and the output shaft got connected directly, right. And when we went to the fifth gear, when we want to go from the fourth to the fifth gear, we push the what to say selector fork down, and that is going to result in the synchronizer moving to the right, and now we can see that this is the fifth gear, okay, and that is engaged. Okay. So, now what happens with this reverse gear? Reverse gear, there is something called as an idler gear, okay, typically, because in the reverse gear we need to change the direction of motion. So, we have one more gear, and how is reverse gear typically engaged? We bring the vehicle to a stop, and then we press the clutch, the brake, and then we engage the reverse gear. So, the reverse gear still works as pushing this idler gear in between these two gears on the input shaft and the output shaft. We have to manually push the corresponding idler gear between the two gears on the counter shaft and the output shaft. So, when we engage the reverse gear, you can see that the idler gear has been shifted, okay, and essentially it goes and creates a link between the output shaft and the lay shaft, okay, which was previously not there along this path, and that is how the reverse gear is engaged, okay. So, this is how the various gear what to say pairs are chosen, okay. So, the last component which I want to discuss is how these are selected by using what is called as a multi-rail selector. So, what is this multi-rail selector? You can immediately see that I need to engage with these various gears by pushing the corresponding synchronizer, right. So, the synchronizers are pushed by these selector forks, right. These selector forks rest in this synchronizer groove. See, for example, in this arrangement there are 3 synchronizers, right. So, each synchronizer will require a separate selector fork. So, we can see that there are 1, 2 and 3 selector forks, and each selector fork is mounted on a particular selector rod. And how are these rods engaged? They are engaged one at a time, okay, by means of this shift lever, the bottom part of it which rests in what is called as a selector gate. So, what happens is that if you, for example, if you want to engage the first what to say selector fork and push it forward, what do? We want this to be moved in this manner, right. So, we want this end to come this way. So, I would push the shift lever to the right, and then I want to push the blue selector rod forward. That means that this end should go like this. So, what should happen to the top end? It should go back, right. So, if I have a motion to the shift lever which is like this bottom end will align with this selector gate and then push the selector rod forward. When the selector rod 1, let us say, is moved like this, let us say this corresponding selector rod is resting on gear 1 cavity, that synchronizer cavity, it just pushes the corresponding synchronizer. Okay. So, let us say this was selector rod 1. Okay. So, what happens is that this pushes the synchronizer in the corresponding direction. Okay. So, this arrangement is what is called as a multi-rail selector. Okay. So, the shift lever which is under the control of the driver is used to regulate the synchronizer by using this selector rod, selector fork and selector gate mechanism. Okay. So, that is how the selection of the corresponding synchronizer and the gear happens. Okay. So, these are the broad components of multi-speed gearbox. So, I will stop here, and we will continue with our discussion on transmissions and analysis in the next class. Thank you.